Those practice tests is to give you a chance to go in and get familiar, kind of get your feet wet and warmed up before you actually take the actual test. All right, in a few minutes, I'm going to try to go back through and call the people I don't see. We're still in the first 2 weeks, and so that's when it's crucial. I'm supposed to take this attendance. So has anybody got any particular questions?
Are we doing a review today?
Yeah, that's what we're going to do. But I'm partially or mainly relying on you to tell me what you've got questions about. So yeah, this is a review day. If not, I'm going to just go through and hit select things that I think might be sticking points. So well, we haven't. We're just talking about Britland. We're just talking about just the things that we've got to review. You got a little practice test in there. I'd much rather if you have questions, you let me know, or else I can just kind of go through and see if we can work through some of these things together. You see that first problem on there? It's giving you a set of ordered pairs. First of all, I would recommend in one like this to just do the domain first. The domain is what? How do you describe what the domain is?
It's all the X factors.
Yeah, it's all of the X values. In other words, these are ordered pairs here. So we're just going to put the first one. So does that look good?
Yes.
All right. And you got to pay attention to things like this about use comma. You can't just write them in there. All right. And in the range is going to be the other ones, the Y. Okay. Now, the way that a function works is for it to be a function, you can't have anything in the X repeat. All right. If a or another way to look at it, if you have an equation that's solved for Y, you're going to have only one X come to that. If it comes to two different Y values, then the rule is broken. But you'll see there's nothing repeated in X. All right. So this is a function. Does everybody agree on that?
Yes.
Okay, good. Anybody got any questions about why? And if I seem distracted, like I said, I'm trying to do the roster at the same time. I got to make sure and do this during the first 2 weeks, especially. And I know people are coming in late, so that's why so I only got 3 or 4 people I don't see. I'll wait a few minutes and then I'll call.
I have a question.
Go ahead and shoot.
Okay, so on the My Math Lab, the sections vocabulary, the concept and vocabulary quiz, that's the quizzes you're talking about that we have to do?
Okay, let's back up.
It says concept and vocabulary quiz.
All right. Let me see if I can see what you're talking about. I'm going to change the share here. Okay, that down now, you'll notice that it says, let me share it. Those are ones that are created by My Math Lab. And it just says sample tested quizzes. So it says you can take them for practice. But see, I have one that I've built here. Now, if you want to do those to help you, then all the more power to you. I mean, the way this works, this has to do with the, they call it the study plan. So the study plan is just something that's built into My Math Lab to help you find out what you don't know and concentrate on what you do know. So like you can take this pretest, see what you do, find they'll see what you know. Then you can go through and do these things here. And then the review quiz, all of these things in between it. And then you take the chapter post test. And actually, matter of fact, this is for chapter P. We haven't covered anything in P. So you would be starting up here. So
that's mainly kind of like just a review for us to use. We don't have to absolutely get that done and get 100 on it.
It's not anything I've assigned, but it is built in to My Math Lab is this thing called the study plan. And as to my understanding, the way it works, you take the pretest, so the system knows what you know going in. Then you go through all these lessons here. And then you take the post test. and see how you've improved. As I understand, that's what the study plan is. But the things that I've assigned is, first of all, the browser check, because you're going to have that in order to take the actual test. All right, because you're going to have the lockdown browser, and then this is the one that I've installed, and that's what I was just looking at that problem from.
Okay, thank you. And do you know how many test questions will be on our test Tuesday? Just
Well, you can look at this and find out. Let's see if it tells us. Hold on. No, it tells you somewhere. Let's go back and to that thing. All right. I can't remember if it told us at the beginning or not. I thought there was a way to actually see. Yeah, you got 27 questions in here. That's why it says 27 points, I suppose. All right, let's go on to the next one. All right, what about this? Do you remember what this was? The graph of that looked like? If you don't remember, I'll draw it out for you. And then you can tell me. But this is one of those things that's pretty standard. It's circle. So I'll just graph it real quick for you and show you. And I gotta keep doing that and share. I was hoping there'd be a way, but I don't think I can do that. So see the graph of a circle. This is that particular circle because it was x squared plus y squared plus 36. I mean, it's equal to 36. And the problem is with this is you cannot solve it for y and get just one x value. You're going to have two x values. So I'll show you what I mean. Let's see, did I? Well, this is it right here. All right. This was a circle, and I had done it for this class. All right. Well, actually, that's not entirely true. Let me back up. So the key is trying to solve this for y. And I'll show you what I mean. It's taking a while to catch up here. So this was the formula for a circle. All right, or for that particular one. The circle is always going to have the x squared plus y squared. You could even have minus x minus something squared and x plus something squared, and this number would change. What's the key factor is for it being a circle is you've got an x squared and a y squared thing in it. But if we try to solve for y, watch what happens. And this is why it fails. 36 minus x squared. All right. So when we try to solve for y, taking the square root of both sides, all right, you got to throw in this plus or minus. Because remember, for anything that's squared, you're going to have two possible scenarios. In other words, if you got the square root of 4 and you take the square root of 4, you're going to have two things. That's why you throw the plus or minus in front of it when you're solving, because you're going to have plus or minus two, both the square roots of two, I mean four, both two and negative two when you square them. So that's why we do this if you don't understand it. So basically what you end up with is the same x value is going to give you two different y values. And like that first problem, that one was a function because all of the x values were unique. But if you had an x value that repeated and it went to a different y, then you got a problem. So this is why this fails a function test. I mean, probably the easiest way to tell you, if you've got y squared in the function that you're looking at, then it's not a function. Yeah, it's not a function. If you have a y squared in the equation you're looking at or the relation you're looking at, it's not a function. So this is not. All right. And the same would apply if it were something like x plus the absolute value of y. Same kind of thing. You can't just do anything to y and get away with it. But it just still be a function.
Okay, so what if it was like flip flop, like you can't have a function of x either?
Okay. There's nothing wrong with that going that direction. Okay. Because we can solve for x with, I mean, because you always have to be able to solve for y. Essentially, what makes it a function is solving it for y and only having one equation. That's what it amounts to. See, like this one, I wish I could write right here. But looking at this, see, I can easily solve this one for y because there's not, all I have to do is just subtract x squared and I've got it solved for y.
Correct.
So this is a function, whereas the circle one, because when you try to solve for y, you end up with two different functions. Like I said, and the reason why that happens is it's because of this thing. You know, if you have, oh, and the reason this is a perfect, and we do this in math 09 and 7, so I'm kind of assuming that you know about this, but there was this thing called the, and we used it as the kind of part of the complete and square process. It's called the square root principle. If you're solving an equation, x is equal to something, and you want to take this, or it's x squared is equal to, you can take the square root of both sides to get the x out. Now that's perfectly acceptable in it being a function because it's the x. But here is the problem is it's the y. The best way to say it is, I'm just going to write this out. It's the relation okay. So that's the way I would put it for this kind of thing, for a circle, especially. So let's go back over there. So that's fine because y is already nothing being done to it. Doesn't matter what you do to x. So the set of ordered pairs, any set of ordered pairs is called a relation. It could be a function, but we got to test the, we'd have to see it to test it. The first set of components is called what? That was what we just did over there. That's the x values is the domain, right? And then the second ones are called the range. That's the output. That was essentially like the first question we took, and we given the ordered pairs, and we wrote down. Okay. All right, so this is just a matter of putting something in for X. And then this one, once you find out what this is, you put it back in. Anybody got any questions about that? I can go over that. No problem. Hold on a second. Let me write it over here on the board, and then I'll share it. So it's so y f of x is equal to x squared minus x plus 7. X squared minus x plus 7. And we want to find g of 1. I'm sorry, f of, actually this is, hold on a second. Oh, there's two different ones. That's what it is. And g of x is 3x negative 3x plus 4. And then we're going to find g of 1 and f of g of 1. So now that I get it written out, I'll reshare my screen. All right, so this is that problem I just had written. Just had showing up there. So to find g of 1, we go to this equation, this function here, and we're just going to put in 1 for x and see what it is. So that's going to be negative 3 plus 4. All right. So we can just sum it up briefly as f of g is equal to 1. Did I do that right? Or if you got any questions about it, let me know before we move on. All right, now the second one looks like it's kind of complicated because it says f of g of 1. But the whole idea here is you're just doing it a piece at a time. We've already done g of 1, so we know what it is. So this is equal to f of 1. All right. So we're just going to go up there. And we're going to put in everything that we got, which was a 1 in place of x. And it's just going to be 1 minus 1 plus 7. So it's really just f of g of 1 is equal to 7. So there's the two answers that they wanted. So let's go back and share. Well, look at that and see if you got any questions. I'm going to go ahead and put it in so I don't have to take it off so quick. All right, so g of 1 was 1, and f of g of 1 was 7. Go on to the next one. So any questions about that? All right, let's go back and share the test thing, the quiz. All right, so this one's a little bit different. So we've got an absolute value equation. So it asks us for the solution set. So the way that we solve this, remember, the absolute value thing essentially means that the inside could be negative or positive and still be equal to 8. So what's inside of that, those two lines, the absolute value symbol, can be either 8 or negative 8, right? And make that a true statement. So I can easily do that here. While you're looking at that, I'm going to set it up here. So it's really this simple. You could almost do it without really working these out. And I'll show you in a minute what I've done, and you can see. All right, let me reshare. So you notice down at the bottom there on the board, I wrote out x minus 4 is equal to 8 because that's what's on the right-hand side, that 8. So if I just drop the absolute value symbol and write it just like that, that's one of my equations. The other one is if I set those insides without the symbols to negative 8, because that's the one that it could be. So the answer is either 12 or negative 4. And you can check it and see, all right, because if we've got absolute value and we do, what was the thing? Oh, it was 12 minus 4 is equal to the absolute value of 8, which is equal to 8. And then also negative 4 minus 4 gives us the absolute value of negative 8, which is also equal to 8. So see, both of those work by just dropping the symbols, the absolute value symbols, and writing it just like that for one of them, and the other one you change the 8 to a negative 8. That gives you the two different equations to solve. Any questions about that?
So your answer is both 12 and negative 4,
Yeah,
right?
because both of them make it true.
Right.
So with an absolute value sign, you're going to end up with at most two solutions. There is a possibility there could be one, but you could have the possibility of two. In most cases, you're going to have two of them. Because all you want to do is have that inside either be one of two things. In this case, it's either going to be 8 or negative 8. And like I said, the original one looked like this. All right, so this is what I was testing here. So I put it in 12, you see I get an 8, and of course the absolute value of 8 is equal to 8. If I put a negative 4 in, then that also gives me, well, that gives me a negative 8, which is also an 8. Let's see, let me switch back to the other mode. All right, so this one hopefully should be pretty easy. Like I said, it's got a lot in here, 27 of them, but some of these can be answered pretty quickly. That's really just a straight line. All right. If it were x is equal to 14, which is a vertical line, then it would fail the function test. But if it, even if it was y is equal to 14, but this is a line. Looks something like this. So yes, that's a function because there's nothing being done to y there. All right, so here's another one. They give us a function and ask us to evaluate. Let's go ahead and work through that. I'm going to write it down. So we've got just one function that they call f of r. Sometimes they'll use different variables to be descriptive of something. This might be having to do with radius. So that's why they use r. Okay, so there's the function. I'll show it to you in a minute. And let's just see, and then I'm gonna type this out.
So like this one here, are you going to be plugging in that -8 where the r is and then solving?
Exactly.
Okay.
And we'll do that with all three of them. And then just, if I can simplify it as much as I can. I'm writing it here on the board, so. All right, so let me reshare. Okay, so it was -8, wasn't it? Yeah. Okay, so -8. So this is A. And so the inside, when you do that, is going to be equal to 0, right? What's the square root of 0? It's just 0. Okay. So that's all that function notation means. It just means plug in. I'm hoping this is going to be a perfect square. If not, we'll just have to leave it. Well, yeah, this is going to be the square root of 64. And the square root of 64 is 8, right? Okay, question so far? All right, so now this next one, this again, it's just functional notation. It means put that in place of R. So the 8 is still in there. And then these things are going to undo one another, and you're just going to have the square root of x. Nothing else we can do with that. All right, any questions about those three?
So you wouldn't keep the parentheses x minus 8 together under the square root? No,
Well,
that's
it is,
better.
isn't it? I mean, I could put this like that if you want, if we wanted to, but what's going to be the result? The same thing's going to happen when you simplify it. The -8 plus the 8 is going to give us 0, and we
0.
would still have the x in there.
Correct. Okay.
But they are going in there together, and they're just replacing r. Let me see if anybody of these people come in. So did Chelsea Acosta come in? How about Lanisha Cloud? I didn't hear anybody come in since I did this. Taylor Ebersole, she come in? Troy McGee? And Nicholas Mertz, did he come in? Okay, so I got everybody else. All right, let's go back and see what's on that next. Well, let me put the answers in. You can keep looking at that, and if you got a question, let me know. All right, now this next one is the one that uses the square root principle, and it'll kind of illustrate what I was talking about when we were discussing the nature of a function and why y squared breaks the pattern of a function. But this is all right, okay? And the reason why it's all right is because it's the x that's squared. Now they just call it equation, but it is a function. But I'm gonna write it down here on the board just to take a gander at it. And then if we don't finish everything today on this sheet, or if you got more questions, on Tuesday, we could still review because the test is going to be open for that outside of class that whole day. What is next? Is it the 31st, right? So it'll also be open Wednesday, and then it'll close at midnight on Wednesday. Well, yeah, at the stroke of midnight Thursday, it's closed. It closes at 11:59 Wednesday night.
So we can come to class with Tuesday with more questions and then go and take our test after later
Yep.
that day. Okay.
All right. I wanted to try to go slow and make sure we had enough time for this first one to make sure we're all on the same page. So, it's not a big push off the cliff for you. All right. So let's go back and look at the board, and we're going to solve this thing right here. And this is using what they call the square root principle. It's essentially the last step of the completing the square process. All right, and then when we do that, we got to throw in the plus or minus square root when we take the square root, because the way square roots work is that both the negative and the positive, when it's squared, give you the same value. And I'll explain that in a minute when you see it. So that comes out. The reason why we're taking the square root is to undo the square. So over here, it's plus or minus 9. And so that's true because 9 squared is 81, and -9 squared is also 81. So that's why there ends up being two solutions. And this is also the principle behind why when you do the quadratic formula, you have the plus or minus in front of in front of that big square root symbol. And I'm going to add 3 to both sides. So here's my two solutions. Since they're both numbers, it's easy enough to put them together. It's x equal to 3 minus 9, and x is equal to 3 plus 9. All right, so x is equal to -6. Okay. And you can kind of see this. We could just check these. The 12 is easy enough to check because 12 minus 3 is 9. 9 squared is 81. -6, -3 gives us -9. -9 squared is also 81. So both of these are the solutions. If you got any questions, I'm leaving it up there so I can put in the answer there. All right, so this one, next one is about domain and range. This one I don't really need to, there's nothing much I can do on the board. I'm just going to kind of blow this thing up. All right. So they're asking us a few different things about this. All right, they're going to ask us what these functional values are. They're going to ask us the domain. They're going to ask us the range, find the x-intercepts and the y-intercepts, if there are any of those. All right, let's make it big. And I do think we can blow this up. But that seems to be all we can blow it up. All right. Let's see if I can blow it up more. Yeah, there we go. All right. So remember, what does the domain it means? It means we're looking at x, right? If we had, when we had those ordered pairs, we were just looking at each one of the ordered pairs, the very first value before the comma, which are the x values. All right. So just ignore the y-axis for right now and just pretend this is a parabola. It's going up and it's going up and it's going up. And one of the ways I like to think about this is if I were to take that like line there and it's going up and it's eventually going to cover this whole thing. But let's just say I was to fold this thing down even more, then what's going to be covered up? Remember, that arrow means it's going on and on. How much of the x-axis is going to be covered up on the left-hand side? It's got that arrow. How about it's going to go all the way to negative infinity? Does that make sense? Okay. This thing is
Yeah.
going up and up and up and up and up and up, and eventually it's going to cover up that whole x-axis on the left. So therefore, on the right, left-hand side, it's going to be negative infinity. And then the same concept holds on the right. It's going on and up and up and up and up. And like I said, it's the way I like to think of if I wanted to take that arrow and just bring it down and pull it to where it was even with the x-axis, how much would it be covered up? Well, all of it, because that point means that it's going on and on. All right, now the range, we can forget about the x-axis now and just look at the y-axis. Hopefully this one might be a little bit easier, because what's the lowest point on the y-axis? It's right here, isn't it? That's what we call a vertex. That's the low point. It goes down there and then it starts heading back up. It'll never get any lower than this. All right. It's just a plain old quadratic function. It's not anything, it's not going up and coming back down. It's just up, up. That's what the arrows indicate. So they have that marked as -5. All right, now, same thing now with the y-axis. You could even fold those two things in, and they're going on and up and up and up. How much of the y-axis gets covered? Is it not all of it? Just like it was for the x-axis. All right, so all right, so for C, it says x-intercepts. And I'm kind of a little bit wondering about something now that I've blown it up, that it distorts something. No, it's definitely -5. It's just compressed on the y-axis. So it's crossing the x-axis is being crossed at this value here and this value. Oh, I see what's going on. Okay. Oh, I'm going to go back and fix something. I see what's going on now. They're only labeling the 5s. Okay, I get it. So really, this should be a -1. All right. So this label is for the x-axis. This label is for x-axis. This one's for the y, and that's for the y also. So each one of these is 1, 2, 3, 4, 5. So this would be -1 is the lowest. All right. So back up on that one. Okay. So now, where it's crossing, the x-axis is -1. And what's that other one? Here. One of the things
+1.
is +1. Good. One of the things about parabolas is they're symmetric. This one, since this one is right on the y-axis of vertex, once you find one, it's going to be symmetrically that much on the other side. All right. And then the y-intercept is where it crossed up here, and that's -1, right? And just to reiterate, we talked about this, but there's going to be only one y-intercept if something is a function. All right, so f of 2 and f of -2. So what we're going to do is, remember, the input is x. So we go to 1, 2, and go up. And it looks like that's 1, 2, 3. Let me know if I'm right. And you know what? On the other side, the same thing because it's symmetric. So it's 3 and 3. So that's pretty much it. If there's any of those you don't understand, let me know before we move on to the next one. But that's pretty much it. Okay. Oh, there's something else. Missing function values. What is that? Oh, that's these. Okay. That's the missing function values. And, in the offhand chance, if they had given us the y of a and ask us what goes in here, you'd have to look at, count this much up on the y and then go across to x to see what it was. All right, how do we get to that next one? There it is. All right, so back to completing the square. I think it was our first day that we talked about completing the square. Let's go back to our board. This was the problem that I saw, I did for you. So we're going to go ahead and use it. What happened? 2. Actually, they're not doing full blown complete the square. They just want to ask us the number that makes it a perfect square. And so that's this part here, but let's go ahead and erase this. Two x plus 2x. All right, let me go ahead and just erase. So this right here always holds true, that the way you find the number that's going to be complete your perfect square is you take half of b and square it. So there's probably going to be a full complete and square question in here at some point, because we already looked at the square root principle, which is always the last step, the complete and square. And now we're looking at finding the missing piece. All right. So the way that we find out what goes here is we take half of this. And the reason why what we call it b is because of this thing. It's ax squared plus bx plus c. So that's where the b comes from. All right, so the b is the number in front of the x. So we're taking half of that. So half of 2 is 1, and 1 squared is equal to 1. So then they're only asking for that value right there. But see, now this can be written as okay, and that's what the completing the square process is. So that way you can use the square root principle to solve an equation with it. This wasn't an equation, it was just asking for that number. So let's see, I'll fill it in. If you got any questions about that, let me know. So those were the 3 things they wanted for input. All right, I'll show you. Say they wanted us to find the number, they wanted just to write out the trinomial and then square it, or factor it, they call it. All right, so graph. All right, now the absolute value is simply just a V. All right, it's a V rather than that parabola thing. Like I said, it's very similar, and that's why if you don't, the Y has an absolute value on it, then it's going to break some function rule. But anyway, the most basic one is, let's see. Oh, wait a minute. We want this one. There we go. So there we go. And see, it goes through 1, 1. Now, the way that functions work, they want us to do the second one. It says x, absolute value of x plus 1 for the next one. Let's see if they can let's do two of them. Okay. Okay. All right. So what happens when you have something outside of the square or outside of the absolute value of x? Then what that essentially is, it means that it's shifting it up or down depending on what that value is. In this case, it's plus 1. So it's just going up one hop. If it were -1, it would go one up.
So for the test, if they have one like this, that we have to draw and mark, the first one would go on the x-axis and the next one would go on the 1.
Yeah, let me,
Like that.
so the next one would go right here, like that. So there you go. That's the 2. See, and then they're going to just ask you verbally what happens. The graph of G is a graph of F shifted 1 units vertically up. If it had been -1, it would go down. Now, we're not, I don't think we really get too much into this in this section, if I remember correctly, but we might, I'll explain it. But if there was something inside of the function, in other words, if it was x absolute value of x minus 1, then that does the opposite thing. It goes along x. And so x plus 1, absolute value of x plus 1 would shift over 1 to the left. It's just the opposite sign. And then x, absolute value of x minus 1 would go 1 in the positive direction. So this is the answer. It shifts up. If it's outside of the function, it just shifts it up and down, depending on what the sign is. All right, so we're about halfway, like I said, and this is about kind of how I was timing it. All right, so this is another thing. A company that manufactures bicycles has a fixed cost of $100,000. It costs $150 to produce each bicycle. The total cost for the company is the sum and its fixed cost and variable costs. Write the total C as the function of the number of bicycles produced. Defined. All right, so what we're going to do is, in order to get this shop up and running, you got to pay $100,000. In other words, and that's just to produce one bicycle. All right, even if it were just 0 bicycles, to get the shop up and running, it's $100,000. So each bicycle then is going to be $150. So what we're doing is, so it's 100,000. I'll write it over here, plus 9 times 150. So the total cost is going to be so this is the cost to produce 90 bicycles, because it was a fixed cost of $100,000 and then 90 times 150, which is the cost per bicycle. You could almost write it in an equation as like this. Well, you could write it in an equation like this, just to show you how a linear function would be useful. So that would be the equation for it. And it could be, you could use that for anything where you have a fixed cost and then a variable cost depending on how many are produced. So this is going to be, what's 90 times 150? It's
13,500.
how much?
13,500.
Let's see, is about right.
No, sorry, 13,500. Oh, you're rewriting it. Okay, I see. Sorry.
It's 13,500, right?
Yes, sir.
Okay. So we just got to add those up. So that's going to put a 101. Wait a second. I'm sorry. It's 113. So it would cost $113,500 to produce 90 bicycles. Okay. They don't give you the function, but just kind of showing you that's what it would be if you need to be, because you don't really even need it to do that. All right. So how would we interpret this? Oh, so the total cost was one. Oops, I got to change the share. This will probably be the last one we're going to be able to do because of the time. But we're about halfway through, so we're all right. I'm probably going to take out a couple on the actual. They won't be that short. I like even tasks like 20 or 25. So just I went through and put everything that we had covered. So, all right. So let's see, how can we interpret this? That's not right, because it's saying this would be 13,000. Oh, wait a minute. They want the function up there. You know what? And that's what I just wrote for you. I was saying we didn't need it, but it was C of X is equal to 9. Let's see, what was it? Oops, you know what? I wrote it wrong. It was 150X plus 1. So I'll take that back. Well, I think I had 90X. It's 150X, because the 90 is going to go right in there at the X value. So this one's not right. It costs $90 to produce. So this is the right one. So it costs 113,000 to produce 90 bikes. There we go. Finally get it right. But anyway, over here, I had this backwards. So this should be 150, because that was the cost per bike. There we go. And that's what I put in there. All right, so that should be enough for today. If you got any questions, stick around. I got a few minutes.